So good afternoon. Welcome to the Challenges of the Extreme Scale Multimodal Analytics Applications workshop. A workshop that is being organized by the Marvel project with the support of Examode, OpenDR, and Vessel AI H2020 projects. On behalf of all the project consortiums, I would like to thank you for participating in our workshop. My name is Despoina Kopanaki. I'm a project manager at Forth, a research institution in Greece, and member of the Marvel coordination team. I have the pleasure to co-moderate this workshop with my colleague, Ms. Dora Kalipolitou, delivery manager at Zilus. Dora is the Marvel innovation manager, and she is also a member of the Marvel dissemination team. Let me now introduce you our speakers, starting from Professor Sotiris Ioannidis. Sotiris is a professor at the Technical University of Crete, and he is the project coordinator of Marvel. Dr. Manfredo Ajori is a research scientist at the Information Systems Institute, University of Applied Sciences, Western Switzerland, and he is the scientific coordinator of Examode. Dr. Nikolaos Passalis represents the OpenDR project. Nikos is a postdoc researcher at Aristotle University of Thessaloniki, and he is a member of the technical management team of OpenDR. Last but not least, Dr. Paulo Figueres, a senior researcher at Uninova and member of the Vessel AI dissemination team. Many thanks for accepting our invitation. It is an honor for us to have you here today in this workshop. Let's go briefly over the agenda of the workshop. Sotiris will start with the presentation of the Marvel project. Manfredo will continue with Examode project. Nikos will follow with OpenDR project. And finally, Paulo will present Vessel AI project. Each project will have approximately 15 minutes. Then my colleague Dora will moderate the roundtable discussion and the Q&A session. But why we are here today? What is the intention of this workshop? The idea is to explore research outcomes, research achievements from EU projects related to extreme scale data analytics in various sectors and environments. Within the presentations, the speakers will focus on the key challenges each project has faced or is still facing, discuss how they address them or they are planning to address, and share any lessons learned up to now. Finally, through the presentations, we will be able to define common areas of interest within the project and also common challenges we are facing, aiming to motivate, inspire, and help other groups facing similar challenges. How we have created this cluster of projects. We define projects that are sharing common research topics like extreme scale data analytics, multimodal perception, projects that are dealing with a wide range of sectors and with different levels of maturity. For example, projects that are approaching to the end, such as Examode and OpenDR, with a wide variety of lessons learned to share, and also projects reaching the end of the first reporting period, like Marvel and Vessel AI, to explore the challenges they are facing in such a critical period. Before we start, few housekeeping rules. You can pose your question during the whole duration of the workshop in the B2Match chat. The question will be answered during the Q&A session. Finally, of course, your feedback is very important for us. We have designed a survey, and we would like to kindly ask you to devote 2 to 3 minutes to reply to 6 questions. You will find the link in the chat of the B2Match platform, or you can use the QR code that appears in your screen. So without any further delay, let me introduce Professor Sotiris Ioannidis, who will present the Marvel project. Sotiris is an associate professor with the School of Electrical and Computer Engineering at the Technical University of Crete, and also affiliated researcher with the Institute of Computer Science at the Foundation for Research and Technology. His research interests are in the area of systems and security, security policy, privacy, and high-speed networks. Sotiris, the floor is yours. I will stop sharing now.
Thank you, Despoina. Let me start sharing my screen. Share. And I'm going full screen. So hopefully you're able to see my screen now.
Yes.
Right. So so first of all, let me thank you, Despina, specifically for all this effort you put in, but all the other people that were involved in this, and of course everyone that is online with us, listening to what we have to say and sharing our experience with everyone. So I'll spend the next 15 minutes or so going over the Marvel project and talking about some outcomes and some challenges that that we face and are facing as this project is taking, it's moving towards the final phases. So Marvel is about this processing lots and lots and lots of real world data in a manner that can be even real time. So it faces a lot of problems in terms of dealing with this extreme scale data analytics problem. Let me see if I can move there we go. Very briefly, the project is a 3-year project, 6 million budget, 17 partners, and it primarily focuses on research, but we do have pilots that actually validate the outcomes of the project. In terms of the consortium, we feel we have a nice spread over academia and research centers, as well as big industry and SME. So we feel we have a nice coverage in terms of the problems that each one of us faces in terms of big data analytics. And also we have specific cities that take the role of validators and pilot providers to validate all the things that that the academics and the businesses actually build. Let me start the core of my presentation now, talking about what drove us to this problem and why do we feel that it is important to solve. So the way we view cities nowadays, from the perspective of engineers and scientists, is that they are these producers of data. They're data engines. They produce all sorts of interesting things that we can collect and that we do collect with sensors, be it video or audio or temperature or vibration or whatever else. And all this data begs us to analyze it and use it to make our life better and the citizens of the city better. So we feel that there is value in this data. And of course, the tricky part is being able to extract this value, this knowledge from the data, and be able to utilize it in some way. And we feel, of course, that the commercial value is quite important here, because there has to be some sort of tangible benefits into using this data. Now, of course, to accomplish these things, we need to be able to analyze them properly and make useful predictions by doing this analysis. But for doing this, there's tons of research that need to be made, and we need to develop new techniques, new methodologies, new algorithms, analyze this diverse type of data in ways that would get more value than the individual sets. So there's a multiplicative effect by combining different types of data. And at the end of the day, the technical challenges that we face is this huge problem of managing and analyzing extreme scale data analytics. Because as I said, there's tons of sensors and tons of data that come to us in real time. If you had to look at one picture to get an idea of the way we envision Marvel, is to just look at this picture. We have visualized a city that creates these events, and these events can be an accident that takes place, or maybe crime that is happening or some siren that's going off, all sorts of things. And these events are being captured by these various sensors that we have. And data is great to have, but we need some sort of intelligent way of processing this data. And that's why all this AI and ML component of the work is in the part of this project. Now, to be able to scale it, we look at the problem from the point where the data is collected, so from the edge, but we also view it all the way through the spectrum back to the cloud. So computation can happen at any stage and has to happen at every stage. And as we're dealing with, as I said, tons and tons and tons of data. And of course, everything that we build, and we're as we're scientists, we always need to have some sort of benchmarks that evaluate the outcomes of the work. And these benchmarks can be, purely performance benchmarks that we use in academia, but it can be more tangible things that industry uses, increasing sales of something or better products that are built. And of course, also societal aspects. Is my life safer now that Marvel created this infrastructure and we're able to detect, accidents as they happen? Now, all this is technology that is being fed into what we call the Marvel solution and the Marvel framework. And the outcome of this is understanding what event is taking place, as improvement of our safety and of our life. So better well-being for all citizens, better decision-making by the policymakers. Okay, we need to make this road one way because that way is going to improve traffic and is going to reduce accidents. But also at the end of the day, create this corpus, this collection of data and annotated data that others can take and benefit and build better services in their own environments. So we want to be as open as possible. So if I have to go over one sentence for our mission is to collect, analyze, data mine multimodal audiovisual data streams of a smart city and help decision makers to improve the quality of life of their citizens and services they offer to them without violating ethical and privacy limits. So this is quite important to us, and is actually one of the challenges that I'm going to be talking about closer to the end of this presentation. Now, all this is well and good, but how is it actually structured? So this solution that we're building, this framework, is based on 4 main pillars. The first one is this real environment, this real heterogeneous environment that produces data, these smart cities. The second is the architecture of edge to fog to cloud, and this is a ubiquitous architecture that is throughout this environment. It's based on better algorithms and new algorithms for processing this multimodal type of data, and provide, of course, situational awareness by using this different types of data. And at the end, the benchmarks that we actually have to make an assessment of did we make someone's life better or worse? Did we make the performance better or worse? So the benchmark part, as I said, is a key pillar of this whole framework. So it's not just building it, but also evaluating it. Okay, let me go. So far I talked about the framework as a whole and the motivation, but the actual evaluation actually happens in 3 different smart cities. And each one has a different perspective on the kinds of things that they want to do. So for example, we have Trento, and they're interested in monitoring crowded areas, detecting crime, monitoring parking spots or other areas. So they're focused on safety. We have Malta, where they're interested in monitoring traffic, making roads safer. So a different aspect of a smart city. And finally, we have another use case. It's more like a micro pilot, more focused case where we use drones to monitor environments from the sky and create technologies that the drones can use to improve our life. And that's being done in Novi Sad. So 3 different environments, 3 different cities, each one focusing on a subset of, we feel, interesting problems that of course apply to all cities, but we want to evaluate them in 3 different kinds, because not everyone can do everything. So we had to break up the problem into multiple chunks. Which leads me to a couple of achievements that I want to focus on for Marvel specifically, before I go into the challenges. So I think our first achievement was what we call the Marvel conceptual architecture. So the all-encompassing framework that offers these solutions. And this is actually a quite complex system, because it consists of 29 key technological components that have their own functionalities, their own operations, and their own roles. These components we have grouped into 7 different subsystems, depending on the functionality that they serve. So similar components would fall under the same, let's call it subsystem. So we have a subsystem for sensing, for security, for data management, for AI, for optimization on the processing, for the infrastructure, and for the component that actually outputs this corpus that others can go and use. I just have this picture here to show you the complexity. It's not important that we go over the details, but what we try to do is group these various, and I'm not sure if you can actually see my pointer, but we have these big blocks showing the various components and how they interplay with each other. So we have the infrastructure here, which is on the cloud, at the fog, at the edge, which is part of the entire infrastructure. And then we have components like the AI system, the optimization, data as a corpus, I believe security is down here, data management, and so on and so forth. So there's a complex interplay of systems, which makes it quite challenging to build such an architecture. So we're quite proud of our achievement to put this whole thing together and actually make it work. And the way we actually tested it being a functional system is early on in the project, in the first year of the project, our goal was to come up with a working, what we call minimum viable product. And this is a proof of concept version of Marvel, which we built very early on, testing the various subsystems and their interplay, as well as parts of the pilots, to make sure that actually everything works, and to try to identify problems early on. So as the project progresses and goes towards the end of the project, we can actually find these problems and fix them. So it was quite important for us to come up with the architecture and test it very early and do a thorough testing. This showed us a number of shortcomings, which we're actually addressing and we'll keep on addressing until the final product. And I promise I'm coming to the end of my presentation. But before I close, let me focus on the challenges that we had. And there are a couple of challenges which we feel are quite important for different reasons. So first one, and this is a non-technical challenge that we faced, which is the key issue of privacy for the citizens and the users, and ethics for the citizens and the users. So whatever we build, we don't want to be violating the privacy of the citizens, and we don't want to be making any ethical compromises. This whole project is supposed to make life better the citizens. And better does not just mean, oh, the buses are going to run on time. But whatever we do, we're going to do it in an ethical and a privacy preserving manner. So this is quite an important goal, and something very close to at least my heart, and I believe everyone in this project. So there are a number of technical problems that we need to solve here, because we collect data. There is problems potentially with mass surveillance. So we took a lot of steps to anonymize things, have informed consent, look at the algorithms, make sure that there's trustworthy AI and all that stuff, which can complicate things. Sometimes it's very easy to come up with a technical solution that improves performance. But if you take ethical considerations and privacy considerations into the equation, things are not quite that easy. So big challenge here. The other problem and challenge that we faced, and this, I think became quite obvious when you saw the convoluted picture of the framework, is that indeed we have 29 different components. We have an edge layer, a fog layer, and a cloud layer. We have 3 pilots, and cumulatively we have 10 use cases spread across these 10 pilots. So the system is quite complex. And this is something that always brings delays, and you have to be very vigilant and very persistent, both at the management level, but at the technical level as well, to make sure that you overcome these in time, so that you're able to produce an outcome that is actually delivered on time and working correctly. So challenges: 1, ethical privacy, so non-technical, and 1 really technical, which is part of the integration. And with this, I would like to close my presentation. We have some information here in the slide about where you can find us, when you can contact us. And I'm sure I went a bit over time, and I apologize for this.
Thank you, Sotiri, for the nice presentation. Looking forward to hear the challenges and the achievements of the rest of the projects.
I'm going to stop sharing now.
Yes, please. In the meantime, I will present, our next speaker, Dr. Manfredo Ajori, is a research scientist at the Institute of Information Systems of the University of Applied Sciences, Western Switzerland. And he is also an assistant professor of deep learning applied to neuroscience and rehabilitation at the University of Padova in Italy. He is the scientific coordinator of the Multi-Modal project. His research interests are related to applied machine learning and multimodal data analysis. Manfredo, the floor is yours.
Thanks a lot, Despina. Okay, so I share my screen. Okay. Actually, didn't request me which screen to share. I think. Is it the right one or not?
No, it's the one with the
notes. Yeah. Okay. Okay, now it should be the right one. Okay.
Yes.
Okay, thanks a lot. So, hi to everybody. So as Despina was saying, I'm Manfredo Ajori, the scientific coordinator of the Multi-Modal project. So Multi-Modal stands for extreme scale analytics via multimodal ontology discovery and enhancement. Thus, actually, the challenges and the objectives faced in Multi-Modal correspond very well, I think, to the main topics of this workshop, which are related to the challenges in extreme scale multimodal analytics applications. I mean, this is exactly what we are trying to tackle, except maybe for the ontology related part, which is a way in which we are working on this. Actually, despite all the challenges, I'm happy and proud actually to say that Multi-Modal is advancing well with plenty of scientific and technical innovations, which are actually bringing us to the planned objectives, and which hopefully can help the scientific community and you then as well. So let's start from a short overview of the project. Well, extreme scale multimodal data are actually continuously produced worldwide, We can think about the internet. We can think about data that we collect with our smartphones or other devices, images, text, images as well of different kinds can be acquired in the biomedical domain. In this context, actually, the biomedical domain is particularly important. It is the size of data produced in the biomedical domain in 2020 only was expected to be around 2000 exabytes. Biomedical data actually stand out among the other data produced worldwide in terms of the included knowledge. In particular, we should think that images, signals, other kind of genetic data or other kind of information is often related to diagnosis or other kind of information which is provided by medical doctors. As well, biomedical data stand out in terms of their economical value, because actually the healthcare market is pretty big and data can be a huge resource into this context. Regarding the size of biomedical data, you should think that in this moment, while we are talking now, actually thousands of hospitals worldwide are most likely acquiring thousands of, I don't know, MRI images, clinical exams, instrumental exams. Thousands of medical doctors are performing the diagnosis. So this is really a huge amount of data. Among medical data, actually, histopathology imaging is particularly important. Well, why? First, because it represents the gold standard for cancer diagnostics. You can see an example of histopathology image here on the top right. Those images, which are normally analyzed by pathologists at the microscope, represent the gold standard for cancer diagnostics. And as well, they represent a market which is currently strongly growing in digitalization and in the development of services which aim at helping pathologists. Deep learning demonstrated to be a useful resource, actually, in biomedicine. In recent years, many algorithms have been developed, for instance, targeting computer-assisted diagnostics, medical image retrieval, medical image quality control, as well as similar applications in instrumental analysis too. Machine learning can allow to, in the clinical practice, to reduce the diagnostic times, to improve the reliability of the diagnosis, and it can lead actually to other types of innovation, which I think will be crucial in the next years, for instance, targeting personalized medicine. However, several limits prevent extracting knowledge and value from medical data, hindering actually the possibility to create a truly database healthcare economy, hindering clinical practice improvements, so for instance, targeting precision medicine, and hindering as well improvements in terms of data management, targeting, for instance, the storage of biomedical data, their transfer, their analysis, maybe in real time. Actually, into this context, Examode started into 2019 and is planned to end in 2023. It includes 7 partners from 5 different countries. Divided, we have 2 academic partners, so the University of Padua and the University of Applied Sciences, Western Switzerland. We have 2 medical partners providing data on one side and evaluating the resources on the other. So the Catania Hospital and the Radboud University Medical Center, which actually strongly contribute as well on the analytic part. Okay, so in developing all the clinical applications. And we have 2 industrial partners, which are CMAI and Microscope IT, which instead try to develop prototypes and products from what we work on in the project. The project structure is divided into And actually, this is a final partner, which is the SURF, so the National Dutch Computational Center. The project is divided into 3 parts, which target knowledge discovery, knowledge application, and knowledge exploitation. So we have mainly the academic part in knowledge discovery, the Radboud University Medical Center in knowledge application, and the 2 companies in the knowledge exploitation part. Well, but what is the overall objective of Hexamote? What we are trying to do? Well, we are trying to create methods to perform easy and fast weakly supervised knowledge discovery of exascale heterogeneous data in highly specific domains. Well, what does this mean, really? Actually, one of the main challenges in the biomedical domain is that it's extremely difficult to gather data and annotations by experts, okay, to train, for instance, deep neural networks. What are we doing in Hexamote? Well, we are gathering thousands of images that are acquired into the clinical practice, into hospitals. We are acquiring from hospitals diagnostic reports associated to those images, so reports which were already created into the clinical practice. And we are applying natural language processing algorithms to the diagnostic reports and computer vision algorithms to the biomedical images, trying to extract multimodal ontologies representing the diseases from those data seamlessly, with basically bypassing human interaction and creating, on the basis of those multimodal ontologies, products and prototypes that can help pathologists in their clinical practice. What are the key challenges into this domain? Well, first of all, to obtain and manage large data sets. Current state-of-the-art machine learning requires large data sets to train solid algorithms. And those are actually particularly difficult to obtain, as said, into the biomedical domain. One problem of the techniques that we are developing is that actually, if we want to avoid having strong pixel-wise annotations by medical doctors, we need even larger amounts of data to train deep neural networks sufficiently well. What did we do in this context? Well, we collected over 40,000 digital pathology images and related text, which are now stored on the SURF infrastructure, so on the National Dutch Computational Center, which helps us to manage them and analyze them with high-performance computing. As well, we develop methods to bypass the requirement of data annotations for training deep neural networks by using directly diagnostic reports. A second challenge was to exploit data heterogeneity for creating algorithms that generalize better to the clinical settings. What does this mean? Actually, currently, computer-assisted diagnostic algorithms do not easily generalize to clinical settings in digital pathology, particularly due to the variability of the images, which is related to physiological variability or color and staining procedures, which change strongly the colors. What did we do in this context? Well, we released libraries and neural networks, which are in most cases actually publicly available on our website, addressing data heterogeneity in terms of color, scale, and several other things. A third challenge was to seamlessly link semantic concept to visual content. What does this mean? Actually, medical ontologies are already available, okay, currently. They are growing along the time. However, first of all, they not necessarily focus that much on specific pathologies or on specific topics. And second, and most importantly, they do not include visual content representations of the diseases, or vectorial, we could say as well, representations of the diseases. What did we do in this context? We created multimodal and multilingual transformers aiming at extracting knowledge from multimodal knowledge from the reports and the images. And we are using those models to creating multimodal semantics ontologies for digital pathology, when instead text-based ontologies were already developed in the course of the project. Key achievements that we obtained, well, first of all, data. I mean, we are here because data is getting increasingly important, and extreme amount of data are getting increasingly important. As said, we acquired over 40,000 images in total. Over 20,000 of those are actually proprietary images with the associated reports. Actually, each pathology image can easily be 1 GB or 2 GB. So this is quite a huge amount of data. As well, we acquired over 20,000 publicly available images and text, basically searching on the internet, challenges, competitions, scientific literature, essentially to try to develop models that can generalize to other contexts too. Second, the first advancement that we obtained, and the second achievement that we obtained, is related to semantic knowledge extraction. In particular, we developed several tools to create automatically ontologies from the diagnostic reports. For instance, the University of Padova released Accessor, which is a web app allowing to, including several apps like SketApp, which targets the extraction of concepts from medical reports in digital pathology, and MedTag, which is an open source biomedical annotation tool for diagnostic reports. As well, said, we also publicly released ontologies for the use cases that we are targeting in Hexamode, which are colon cancer, lung cancer, celiac disease, and uterine cervix cancer. And we released the ontologies for those diseases on our website. Third, we developed weakly supervised learning algorithms for starting from reports. And here on the right, you can see some of the results which we obtained, which actually allowed to provide very good performance in the classification of host-side images and in distinguishing between if there is cancer or not, or other kind of diseases such as dysplasia, the presence of polyps, or other things too. The nice thing of this analysis process is that actually it is made essentially starting only from the clinical data, including images and reports. In this context, we are advancing currently on using multimodal models, so really merging together images and reports. As well, we released on the Grand Challenge platform several algorithms targeting, for instance, neural image compression, so developing neural networks that can compress strongly, I think up to 90% around approximately digital pathology images. And we released also, for instance, for the segmentation of tissues in histopathology images of lung and breast. Those results led to several products and prototypes which were developed in Hexamode. Among those, the first one that I would like to mention is Virtum, which was developed by Microscope IT. It involves tools targeting the annotation of digital pathology images, the classification and segmentation of tissues in digital pathology images on the basis of the algorithm developed in the other work packages, and tools also for retrieval in digital pathology based both on text and content-based information. Finally, I would like also to mention Isographer, which is a software platform developed by Sirma AI, so Ontotext, and which aims at building holistic solutions integrating multimodal histopathology data, with the aim of supporting histopathologists in making more informed decisions based on large amount of data on previous experience, previous diagnosis, and so on. So really more informed decisions and diagnosis. All of these results actually concretized into over 70 journal or conference papers that were published, several and obtained over 640 citations until now, over 17 open access software libraries, and several workshops, conferences, challenges. All of this information is, or most of this information maybe is available on our website. So feel free also to check it at www.axelmont.eu.
Thank you, Manfredo, for this nice presentation. Actually, yeah, you can obviously see what you have achieved now that you are reaching the end of the project. Hopefully we will do the same. Okay, so let's now move to the next project, OpenDR, while Nikos will try to share his screen. I'm going to present him. Dr. Nikolos Passalis is a postdoc researcher at the Aristotle University of Thessaloniki. He's a member of the technical management team of the OpenDR project. His research interests include deep learning, information retrieval, time series analysis, and computational intelligence. Nico, the floor is yours.
Thank you very much, and thank you for the invitation. So, in this presentation, I will talk about OpenDR project, which is a project regarding an open deep learning toolkit for robotics. In this presentation, I will go through the main objectives of this project, the motivation, as well as the challenges, some of the challenges that we have faced, as well as the current results that we have. But before we begin, some information regarding OpenDR. OpenDR is an H2020 research and innovation action. It is coordinated by the Aristotle University of Thessaloniki, and Professor Anastasios Stefas is the project coordinator. And we have 8 partners from 7 European countries. 5 of them are academic ones, and we also have 3 industrial partners that work on the use cases of the project. The duration of the project is 48 months, and the project ends the next year. So we are about in the middle of the project. Now, before presenting the actual aims and objective of OpenDR, I think it's important to understand the context that actually led us into conceptualizing the idea regarding OpenDR. And as we all know, I think it's obvious until now that deep learning has transformed many different areas, and of course robotics is one of them. However, robotics leads to some research questions that are not typically addressed within the deep learning community. And there are 3 major axes OpenDR works around. The first one is the steep learning curve that deep learning tools often have. We found out that people working on robotics are typically more familiar with more traditional computer vision pipelines, so they face a difficulty when they have to use deep learning tools. They are interested about deep learning tools because they achieve a significantly better performance. However, integrating those tools and learning how to use them is quite difficult. The other one is the computational complexity of deep learning. Of course, deep learning progressed due to advances in hardware. We have powerful GPUs and even specialized accelerators that allow us to train big and powerful models. However, in robotics, the situation is a bit different because there we don't have the luxury of having big computers. In some cases, we have to deploy the models in embedded systems. Of course, the need to have deep learning models in the edge and in embedded system led to the development of embedded boards that can accelerate deep learning. However, significant computational power exists limitations exists in such cases. And the last one is what is called passive perception. It refers to the way that the traditional computer vision approach is tackling the problem of perception. In traditional computer vision, we typically take a static view of the world. We have an image, we analyze this image, and the output is that. We don't have any possibility of interacting with the environment. However, this is not how humans and other, let's say, biological organisms work. We typically interact with the environments. Robotics have the ability to interact with the environment. For example, if we see an object and we are unsure about this, we have the possibility to move the robot towards that object in order to get a better view and potentially increase the precision of perception. So, all of this leads us to the main objective of the project, which is to develop a modular, open, and non-proprietary toolkit that will allow us to provide deep learning tools that will provide perception and cognition capabilities that address these challenges. And more specifically, we aim to overcome the learning curve barrier by providing an easy-to-use library. This includes a collection of ready-to-use ROS nodes, as well as the necessary tools for training and development. We also aim to overcome the computational complexity barrier by using a wide range of different techniques to make deep learning models faster and in some cases be able, actually in all the cases in this project, we aim to have real-time inference on embedded devices, but we also aim to be able to process high-resolution data, which in many cases is critical. For example, if we have a drone flying in a significant height, then we need to have high-resolution sensors and process the data in high resolution in order to have an accurate results. And we also aim to overcome the passive perception barrier by developing a co-simulation and training environment that will allow us to integrate perception and sensing and control. Sorry. OpenDR aims to validate the developed toolkit in three use cases. This is healthcare robotics, agricultural robotics, as well agile productions. Each of the three industrial partners are working in one of these use cases. And we can proceed to understand how actually OpenDR is structured. The main idea of OpenDR toolkit is to lie in the intersection between simulation environments, such as Weebots and other ways to simulate the world, tools that are used for robotics development, such as ROS, as well as deep learning frameworks. As we all know, there are myriad of deep learning frameworks. Of course, we are not aiming to reinvent the wheel, but we are trying to reuse as much as possible standard and well-accepted tools such as PyTorch and TensorFlow, as well as formats that slowly emerge through this through the deep learning community, such as ONNX for storing deep learning models. So the aim of OpenDR is to provide a common place that will merge all this into an easy-to-use tool for robotics. Now, the main work of OpenDR is divided into three main sections. This concerns human-centric perception, which is the work package 3, environmental perception, as well as robot action and decision-making. We do not have an explicit multimodal reference here, as you can see. However, multimodality spans across all the work package and all the work of OpenDR. For example, in work package 3, we have multimodal human-centric perception cognition, we have sensor information fusion, and of course, multimodality is an important aspect in human-robot interaction use case. To better understand how we ended up structuring the toolkit, we followed the structure that is shown in this figure. The main part of the toolkit is written in Python, and we have a training submodule that allows us to train different tools and models for different works. And the output of this submodule is the trained deep learning model. And then we have a separate interface, which is the inference interface, that takes this model, and this is actually the interface that we expect most end users to use. Of course, Python is very good for prototyping. However, it's not what somebody is probably going to use in most practical matters. So we also provide two additional interfaces. The first one is a C and C++ interface for using this model, as well as ROS nodes. Furthermore, we also have a simulation interface that allows us during the training process to talk and have a back and forth through simulation in order to integrate simulation and training, which is quite important, especially for active perception tasks. I will not go through many details there. What I want to say there is after a lot of work, we ended up having a class hierarchy in the toolkit, and we tried to separate our work into having an engine package which contains the usable definitions of the core functionalities of OpenDR. We did this in order to ensure that we are going to have a homogeneous interface along all tools. And we expect also that this will also help when other things will start, other people start contributing into the toolkit, because we have set a strict interface about how things should work. Now, regarding the current status, we have released the first version of OpenDR Toolkit on December 2021. Of course, OpenDR is under a heavy development right now. We are working towards the second release of the toolkit, where we will provide optimized models for inferences with high resolution deep learning tools. And by the end of the next year, we also hope to provide active perception enabled deep learning tools for robotic perception. It is worth mentioning that OpenDR is available through all major distribution channels. We have pip packages, we have Docker images, and we have also support for major embedded devices such as Jetson TX2, NX, and AGX. And of course, we have our GitHub repository, which can be used for directly installing the toolkit. One lesson learned through the development process is that initially we followed a monolithic design where the whole toolkit was included in the pip packages and so on, which is not so practical. So in the version 1.1, which is going to release very soon, I think next week, we are going to provide more flexible installation options that allow us to install only a part of the toolkit, which we think that it will be quite useful. We have several tools that are already included. As you can see, all major, or at least a large part of major deep learning tools such as SSD, YOLO, and so on are included, as well as a version of tools that have been developed through and in the context of OpenDR project. There are many of them, such as efficient PS for panoptic segmentation and several things regarding head anomaly detection and other ones. One other important aspect is that we provide several demos and tutorials for all the provided tools in order to make very easy for users that use the toolkit for the first time to find their way in the toolkit. And of course, we provide those nodes that can be directly used in many different robotic situations out of the box without any change. Okay, and I would like to conclude the presentation by also mentioning two multimodal tools that we have included so far in the toolkit. The first one is an audio-visual emotion recognition tools that merges audio and video in order to recognize emotion. And the other one is RGBD-based hand gesture recognition, which uses both regular and depth cameras in order to understand hand gestures. Of course, if you have any question, we can contact the project coordinator, and you can find more info in opendr.eu, as well as in the repository of the project. So, thank you very much, and I will be happy to answer any question.
Thank you, Nico, for your nice presentation. I think we will have the questions later in the Q&A session. In the meantime, I would like to encourage the audience to post the questions in the chat of the B2Match platform. Also, Dora has posted a link for the survey we have prepared. It is very important for us to hear from you. What are your thoughts for these projects and the challenges they are facing, also the achievements? So, last but not least, Dr. Paulo Figueres is a senior researcher at the Nova Center. He's deeply focused on the areas of knowledge management, semantic web, big data, and Internet of Things. Within Vessel AI, he's a member of the requirement analysis and the dissemination team. Paulo, thank you for being here. The floor is yours.
Thank you, Despina. Can you see my slides? Yes. And can you hear me well? Okay. Okay. So hi, everyone. Thank you very much for this invitation. My name is Paulo Figueres. I'm a researcher at Uninova, and I'm here to present to you the project Vessel AI, which has the extended name Enabling Maritime Digitalization by Extreme Scale Analytics, AI, and Digital Twins. So I'm going to go a little bit through the agenda for my presentation. I'll go through the introduction of the Vessel AI project. I will present some of the achievements so far, since we are, as Despina said, at the end of the first reporting period. And also I will go through some challenges, project-specific challenges, and also challenges related to the convergence between HPC and AI. So the Vessel AI project, or Enabling Maritime Digitalization by Extreme Scale Analytics, AI, and Digital Twins, aims to develop, validate, and demonstrate a novel holistic framework based on a combination of state-of-the-art big data and AI technologies capable of performing extreme scale and distributed analytics for fueling the next generation digital twins in maritime applications and beyond. So the main idea here is to bring the convergence between high performance computing, big data, and artificial intelligence technologies into the maritime domain. Some figures about the project. So we started in the 1st of January 2021, and the project has a duration of 3 years. It will end on December 2023. The project was funded under a big data and high performance computing call with a budget roughly touching the 6 million euros. You can have a look at our website, which is vessel-ai.eu. And regarding the consortium, so we have 12 partners from 6 countries: Portugal, France, Greece, Netherlands, Norway, and Finland. The coordinator of the projects is the National Technical University of Athens, and we have a strong mix of both research institutes and universities, and also industrial stakeholders on important industrial stakeholders on the maritime domain. Regarding the objectives of the specific objectives of Vessel AI, the idea is to deliver a novel, open, and trusted platform capable of multi-stage and distributed data analysis workflows, combining compute and data-intensive capabilities that will fuel a wide range of shore-side decision support and next-generation maritime services. The second objective is to design and develop the appropriate software and hardware components, tools, and libraries that will enable the efficient ingestion, curation, semantic annotation, querying of extreme-scale data sets coming from different sources. And this data will be required for model training and serving, and also for the digital twins and application and real-time applications for the maritime domain. Then we will deliver a set of trained high-quality interpretable machine learning and deep learning models by exploiting this extreme-scale data sets for advanced classification, analysis, and forecast related to maritime entities. The fourth objective has to do with the research and the delivery of a state-of-the-art high-performance computing infrastructure and resources management framework for optimizing the required extreme-scale data processing, models training, and model serving for the maritime digital twins and applications. Of course, we also have objectives regarding the dissemination of the project. That's why I am here today, and also the exploitation of the project. For dissemination, we compromise ourselves to deliver the AI models that we have in the project under the AI for EU framework, and also we are validating and disseminating the work that we have done in Vessel through real-life maritime applications. And for the exploitation, of course, we are getting together and sharing our findings with the important maritime-related stakeholders. And at the end of the project, the idea is to have a business plan for the Vessel AI offering. So to meet these objectives, we have this conceptual architecture. So we have streaming and batch data sources that come from the maritime domains, such as vessel locations, vessel routes, also shape files containing map and layers of spatial information. We will have weather and environmental data also, and data coming from shore control centers and vessel traffic management systems. The project is divided into 5 main technical work packages. So work package 2 has to do with all the collection, data ingestion, data collection, curation, semantic enrichment, and storage. Then work package 4 will train and serve the AI models for the maritime domain. These 2 work packages are built on top of our high-performance computing infrastructure and resources management framework. And finally, all of this will be glued together via our integration and security services, and then will be delivered to our final maritime users and applications. We have 4 pilots on Vessel AI. So the first pilot is based in Greece and is the ship modeling for global traffic monitoring and management, in which we will research and extend different models for feeding vessel traffic management systems and experimental digital twins of the vessels using different machine and deep learning approaches. Then we have the globally optimal design of ship energy systems. So the idea here is to use already existing data for the operation of vessels in the design of the future ship energy systems. Then we have the autonomous ships in short sea transfer. The idea here is to utilize large volumes of data from shore control centers to forecast traffic situation in order to predict the next maneuvers on unmanned vessels for short sea navigation trips. And finally, we have our weather routing and fleet intelligence service, in which we will provide AI-based real-time fleet operation optimization using vessel and fleet digital twins with automated voyage optimization according to weather and different operations. Okay, so The achievements so far, we have more achievements. I could talk about the data that we have been collecting, which are already in the exascale threshold. But the three main achievements that I think are more important to our talk here today are first, so the AI models for the maritime domain. We will have to deliver at least 20 AI models for the maritime domain until the end of the project. But for now, we already have 13 plus AI models trained and ready to be served to our pilots. You have some examples here, such as vessel route forecasting or anomaly and collision detection, among other examples. The second achievement is the Vessel AI HPC infrastructure, which will be a really state-of-the-art infrastructure with the most state-of-the-art technologies on CPU, GPU, TPU, FPGA, and AI acceleration. And you can have an idea of our hardware architecture by looking at the image. So we will have hardware, which will then have cloud services built on top based on containerized technologies such as Kubernetes and Docker. And then on top of these containers, we will have our big data and AI frameworks such as TensorFlow, Keras, PyTorch, or Apache Spark, or any of the Apache Foundation's big data tools. And then, of course, we will have our applications and scripts running on top of these. Last but not least, one of the main achievements that we have is our data analytics environment. So we chose Apache Airflow as the main execution and orchestration framework to run our AI workflows on top of this HPC infrastructure. And we also built a tool, a user interface, and some services that enable users to dynamically create Airflow pipelines through a visual programming interface. I can show you a little bit, just a video of it working, so you can just select your own operators, so data connectors, transformers, or analytics model training operators. You can then just save it, run it on your Airflow instance. But the main achievement on this solution, the data analytics environment, is that you will be able to run this data analytics environment together with your own technology instances running on your own premises or on your cloud. So the idea is that if you already have a TensorFlow instance or an Apache Spark instance running on your servers, you can use this external instance together with our data analytics environment to run AI workflows on your instances and not on the internal instances that we have running on our environment. So for the challenges, I will present really quickly two types of challenges. The first maybe are of interest for people that work on European Commission funded projects, which are the project specific challenges. And then I will present other more generic challenges, more related to the convergence between AI and HPC. So for the project specific challenges, the main challenge that we found appeared when writing the proposal. So when we were writing the proposal, the definition of tasks that were related to both the AI and HPC counterparts of this convergence had to be thought of as these tasks had to evolve dependently on each other. So the main issue here and the main challenge was that the HPC part was only to be delivered on the second year of the project. And of course, you have to understand that proper benchmarking and validation has to be done, and this takes time. And so we had to find a way to use other ways of training, validating, and benchmarking our model training solutions without the help of our HPC infrastructure, which is still being built. And that's why I presented to you our data analytics environment, which helped us to overcome this challenge by being able to be integrated or deployed in different hardware instances rather than the HPC, so that we can at least train our models already and then do some benchmarking and validation there, and then make a comparison when we pass all of these solutions into the HPC infrastructure. Finally, for the other challenges, so the main challenges that we found is the integration and optimization of the conversions between AI and HPC. In this case, the gap between hardware, so our CPUs, TPUs, GPUs, and FPGAs, and the software, our TensorFlow, Storage, Apache Spark, etc. So the gap between the hardware and software must be closed in such a way that the integration between them is optimal. So hardware resources are used in an optimized way on the deployment of these big data and deep learning software solutions. So most of the times, the choice of technologies is also an important challenge. So what big data technologies are more suitable and optimized to run over the different hardware counterparts of an HPC infrastructure? How can we decide what are the best technologies and how to optimize their deployments for CPU, GPU, FPGA, or any other HPC-related hardware? So I don't have a clear answer for this question. Maybe I will have at the end of the project, but for now, I leave this question for the panel to maybe have some discussion on it. Okay, so thank you very much. If you have any questions, please feel free to send me an email via my email on the screen. Okay, thank you.
Thank you very much, Paulo, and thank you to all the speakers so far for the very interesting presentations. We also saw the chat actually getting a little bit activated, so we have a number of questions that are popping in, and we still have luckily approximately 15 minutes to address them. So with that, I would like to open the panel discussion using questions that we have prepared, but also what came in the chat. So a first question that I would like to pose to all of you is that we saw in your presentations the challenges that the projects are facing, and in one way or another, like how in the end you are addressing them. But I think we would agree that there are lessons to be learned also by things that haven't worked out. So the question would be, all of you, what have you tried in your projects that actually didn't work out? And then that could be like a good lesson learned for other people in order like to, to keep that in mind in their approaches. Allow me to start with who I see next to my screen first. So Dr. Pasalis, would you like to pick it up?
Okay, so I can say two different, let's say, things that didn't work. The first is regarding integration. In the beginning, we tried to go with the most recent versions of all tools that we're going to integrate in our toolkit, but then we found out that we have the many incompatibilities between different tools. So we had to revert back and very carefully start from the beginning and select the version that we had to use, this integration challenge. And regarding the actual research, I would say that concerning active perception, in the beginning, we had the impression that we could fully tackle this problem using reinforcement learning. We have tried some vanilla reinforcement learning approaches, but we found out that we had to do aggressive reward shaping in order to have them start working. So it was not an out-of-the-box solution as somebody might think. And we also started working towards supervised approaches for active perception that can achieve the same results.
Good to know. Ambition is always good, of course, so we need to try. Thank you very much. Shall I pose the same question also to the next one I see on my screen? So, Dr. Ajori, would you like to share what you have tried and that didn't work so well, or as you expected?
Yep. So actually, by our side, by a technical point of view, actually I think that we got pretty a good direction from the beginning. One thing that instead was really problematic was essentially interacting with clinical partners, particularly due to the COVID situation. So this essentially blocked everything. The personnel in the clinical partners was strongly devoted to fighting COVID and basically doing tests, analysis, tampons, many different kind of things. And so they were strongly overloaded, essentially. Despite this, they managed actually to provide us tranches of data, particularly at the very beginning. And afterwards, instead, they were strongly exhausted, I would say. We managed to advance with, thanks to the data provided at the very beginning, and this slowed down a bit everything. But still, this was, I would say, one of the big problems that we had, which also actually had consequences on the companies and on the plans for products and prototypes. Other than that, by a technical point of view, I think we are advancing pretty well. And by a scientific point of view, one thing that actually changed during the project was that actually new technologies advanced in terms of multilingual and multimodal data analysis. So, I mean, they were really starting, I would say, at the beginning of the project, and we integrated them into our pipelines. And so finally, it was one of the possible solutions, however, for the directing our research.
So that also turned out to be a good thing in the end, right? Good. Thank you very much. Dr. Figueres.
Okay, so I'm going to go back to the same challenge that I presented before. This was the main challenge of the project because we came to the project beginning and we realized that the proposal was badly written in terms of the scheduling of the HPC infrastructure delivery. And so we had some issues because of that. So one issue was that if you are aiming to have an HPC infrastructure on your project, you're not accounting to have other cloud instance or on-premise servers in order to run your solution. So if you have already an HPC infrastructure on the proposal, you wouldn't need any other servers. And because of this issue, because we will only have the HPC infrastructure available or fully available on the second year, on the third year of the project, we had to come up with different solutions for this. One of the solutions was the data analytics experimentation environment that I showed you, which allows our models to be trained and served in other servers and in other instances, rather than using the HPC infrastructure. But then when the HPC infrastructure will be available, the passing of this data analytics environment to the HPC infrastructure is also already a little bit easier. Another thing that we decided to do was to train the models. We trained all the models not using the HPC infrastructure. And then when the HPC infrastructure will be available, we not only will do the benchmarking and validation of these models, but we also will start to do an auto ML solution in which these models will be updated in almost real time whenever new data is coming to the HPC infrastructure. So more or less, this was, again, a part of all the technical challenges that these projects pose, such as, of course, data collection in the exascale thresholds, also semantic enrichment and annotation of data, data privacy, all of these issues. We also have them on the project, but really my idea was to also to try to say to people that are running for these proposals on HPC, please try to have your HPC infrastructure the fastest ready possible. Okay. Thank you very much.
Thank you. And I think this is something for us to consider as well. Dr. Ioannis is correct, because yeah, we already mentioned that this is also one of our challenges in terms of complexity and all the environments that we have to run. But yeah, would you like also to share something that was tried in Marvel and didn't work? And then you can comment also on that last
yeah, so first of all, I'm glad to hear that everyone else is having problems. It's not just us. So thank you, guys. You mentioned a number of things that we actually faced, like integration and whatnot, and HPC. Oh my God, yes. I'm gonna focus on something that we hadn't really accounted for in terms of manpower and expenses and tasks and whatnot, which is the annotation, which was briefly mentioned, which takes a lot of time and a lot of people, and it's manual. But that is quite important in order to validate things and make sure that your models work properly. And the goal in our project is to have 3.5 petabytes of data, if I'm not mistaken, and it's quite a task to of course annotate them all, and it's something that we decided to do. Of course, we're not gonna reach that number. I believe right now, I guess the numbers vary a bit because we're in different stages of annotation. We have multiple tens of gigabytes annotated, but and still going on. But it's something that it's a good idea. It's something that's gonna make your work better. But if you don't account it for in the technical work, then how do you justify it in terms of expenses? And are you going to spend all your money hiring like 20 people doing the annotation? So that is quite hard. The other thing that was mentioned again in my talk about privacy and ethics, we do have the technologies to deal with these things, but one of the challenges that we thought we had solved, but we hadn't quite solved, was actually getting the initial data, because the partners were eager to share, but then the lawyers always get involved, so it gets harder to release things. But our partners were very good at this, and we navigated these problems. And of course, these are things that always come up. So I think these are the two things that I would like to say as unexpected.
Thank you very much. I think given that we are only left with 5 minutes, I would like to pick one question from the ones that popped up in the chat, and then I would like to invite you to answer, like to get into the chat in the B2Match platform and like answer the other two that are pending. But in order to be fair on the first come first served rule, I will just pick up the first one that came in, and it was the following. It would be good to discuss among projects not only the lessons learned, but also identify industry-driven research challenges that will need to be addressed in future programs. So having talked about the challenges and what worked and what not, would one of you like to pick basically this question and say in their point of view what do you see as a industry-driven research challenge to be addressed in the future?
If you don't mind, I can answer, at least from my side. one of the biggest challenges also in our project, I don't know if in your projects also happen, but it has to do with data storage for HPC. Okay, so data storage for HPC, well, of course, we have lots of distributed technologies. We have the traditional RDBMS solutions. Both of them are now getting more evolved towards these high-performance computing environments. But nevertheless, I think that at least from our case, we have a dedicated partner for data storage technology. In this case, it's a relational database management system, and we are still in the process of validating and benchmarking these kinds of systems for HPC model training. But nevertheless, I think that one of the research topics for the next for the upcoming calls could be this for so data storage optimization for HPC model AI model training and workloads in this case. Thank you.
Thank you. Anyone else would like to comment on this?
Okay, since there was silence by the other speakers as they're thinking, let me just make a comment about what Paulo said. Maybe these calls do exist in the HPC calls. So maybe, I mean, I'm not sure if you're involved in the your HPC calls. So maybe some of these aspects are already there, and the community that is doing big data needs to also look into the people that are doing HPC and see if they can actually get funding from there to do exactly the kind of research that that you talked about, which is actually very important and very difficult. So it'd be good to fund such things. This is just as a pointer. The EuroHPC community is quite interesting, and I'll be happy to discuss this if someone buys me beers. Now, in terms of specific calls and topics, you know what? I think that over the years, the calls have been fairly broad. So I never really, personally, I never really felt constrained that, oh my God, I would love to do this type of research. And, you know, the call text is so limiting that I cannot phrase it in a way to get it funded. Again, I'm going to extrapolate now into other calls because I also do a lot of security and hardware. Also in those calls, I always felt that there was enough flexibility. But then again, that's my field. So I think the Commission is doing a fairly good job in being broad enough to fund a lot of things. One of the quote unquote problems with this is that in trying to be broad, maybe the calls can be a bit confusing in cases, and you're not quite sure what they really want you to write in the proposal, because there are so many different keywords and buzzwords in the call text. But for that, you know, you have the info days, and specifically for the big data calls, the officers have been very good at actually pinpointing what they want to see and how, and then explain the thinking behind the call text. But anyway, that was my experience. These are my thoughts, and I'm gonna let the other two speakers jump in. I don't want to monopolize the time.
Well, to be honest, I think we will have to wrap up, unfortunately, because we are like 1 minute before the top of the hour. Oh. So I would like to thank all of you for your presentations, for your time, and for your knowledge, of course, that you shared with us here. Of course, the organizers like BDBA Dairo and the European Hubs for the yes, and of course Mattia and Sina, who were our hosts today. Thank you very, very much. And please, to our hosts, if you can just jump into the Be2Much platform into the chat box and reply to the questions, that would be really, really helpful. And then we make sure that we address everything that was posed to us. Thank you very, very much. And yeah, any last comments if anyone would like to start?
Thank you all for participating and for accepting the invitation.
Bye.
Thank you very much.
Thank you for organizing this.
Thanks, guys. Take care.
Bye-bye.